Hello students, I hope you're doing well today. I wanted to take opportunity to talk to you about reading meters, okay? We're going to talk briefly about analog meters. This is a Simpson 260. If you look right here at the Simpson 260 and you see right here it says 260 and then right below there this is a Series 6 XLP. So there's various different types of Simpson meters and stuff. And I'm primarily today concerned about you being able to read this display. Now we're going to do some exercises. Those exercises will be won't be in color, but this will show you this matches what we just looked at on the meter. So this is a nice look here. And we're primarily concerned with in our DC classes reading ohms and reading DC. Okay, so those are going to be our scales that are labeled in black. So if you look at, let's take a look at the DC scale, this black part here, DC, this works like your speedometer, okay? So if I'm in my car sitting in the parking lot and this is my needle and I'm coming up and I'm looking at the numbers on top. So if I'm looking here, I'm going 50 miles an hour and then I'm going 100. And then if you come right here around 88 miles per hour, you can go backwards or forwards in time if you're riding in a DeLorean, okay? And so as I go left to right, as my numeric value increases. As I look at the scale for the DC, I have three scales. The very top scale is going to be 250, 50, and 10. So those are what I refer to sometimes as top, middle, or bottom. But I prefer to call it a 250, 50, or 10, or some multiple thereof. And when I mean multiple, I mean this 250 can be 25, it can be 2.5, or it can be 250. And likewise, the 50 scale can be represent 50, 5, or 0.5, and the 10 scale can represent 10, 100, or 1. So those are how the DC scale works. And we'll use that DC scale to read voltage in our exercise. And then the very top scale is going to be used for ohms, okay? And so the DC scale down here at the bottom is, consider that a bucket. And whatever I have this selector knob turned to, you see this selector knob here. And if I look at the selector knob, the way this indicates is I can have this set for 1 volt. 2.5 volts, 10 volts, 25, 100, or 250, or 500, or 1,000 volts. So that's my voltage settings here. Okay. And that would correspond to this scale here. And then if I'm measuring ohms, and so the way the scale works for DC is that you take the measurement. Like if I have this set for 250 and my needle's on the 50, that's 50 volts. If I have it set for 25 and the needle's on 50, that represents 5 volts. So depending on what selector knob you have selected determines how big the bucket is that we're using to measure with, and then we'll measure the scale accordingly. With ohms, you can see is that it is a non-linear scale and it is reverse scale. So all the way to the right, instead of being maximum, is 0, and all the way to the left is infinity. Okay. So the way the knob works here for resistance is I can have my setting up here to R times 1, R times 100, R times 1K, R times 10K. So it is the reading, okay? It's going to be whatever reading times the selector is the value of our resistance. So let's say I have this on 100 ohms. So it's a reading times setting. So let's say I have it set for R times 100, and I'm up here at the very top scale, and I have that set to 4. It's reading 4. That means that my reading is going to be 4 times 100, and I'm reading 400 ohms. Okay. If my setting is for 1K, like here, if I change my setting to 1K, and it's reading 5, that would be 5 times 1K, 5K ohms, or 5,000 ohms. If I have it set for 10K, as I do here, it's going to be my reading. So if it's reading 8 times 10K, that would be 80K ohms. So the way the ohm works, the ohmic value works on my meter here is going to be the reading times the setting is your value. Okay, so we're going to do some actual exercises. We're going to look at homework 3.0 and 3.2 in just a second, and that'll be a separate video, and we'll talk about those individually. Thank you. See you in class.